Welcome बच्चों. In our previous lecture, we have studied about White and Sabert's law and its application. Now, we will study about force acting on any charged particle when it enters in uniform or maybe non-uniform magnetic field. Suppose this is our charge. This Q charge is moving with V velocity. How it is moving? This is Q charge. It may be positive charge. Suppose it is moving with V velocity. Now, if it enters in any external field, suppose this is any external field, may be directed perpendicular to the plane of the paper. Now, when this charge, it is moving with V velocity, and if this charge enters in this external magnetic field, so what phenomena you will observe? This is the charge, and as charge is movable, and when charge is movable, that means current is flowing. What is the meaning of current? It is the rate of flow of charge. So movable charge means current, and whenever any charge is moving, that means current is moving, so one magnetic field will be associated with it. When this charge enters in another magnetic field, now due to self-magnetic field, due to motion of this charge and this external magnetic field, there may be some interaction between these two fields. भाई एक magnet को कौन force लगा सकता है? Obviously another magnet will apply the force. And when this movable charge means it may be the source of magnetic field. And then when this magnetic field enters in another magnetic field, then there may be some interaction, and there is interaction between these two fields. So obviously you will find some force. So whenever movable charge enters in any external magnetic field, there is some force, and this force is known as magnetic Lorentz force. This is known as magnetic Lorentz force. Now see, on what factor this force will depend? Obviously, suppose this is any charge Q, and charge is moving with velocity V. This is any magnetic field. When this charge enters in this magnetic field, so it is observed that, experimentally it is observed that this force acting on this charged particle will be always perpendicular to V. Obviously, this charge V will be perpendicular to B. So it is observed that, first of all, this force M, it will depends on nature of charge, or simply I can say that it will depends on magnitude of charge Q. This force will depends on magnitude of charge Q. This force will also depends on V sin theta. Why I have used terms V sin theta? I have combined this force V and sin theta. We may write in different way also. Fm will depends on velocity. Fm may depends on sin theta. Why this term sin theta is introduced? This term sin theta is introduced because experimentally it is observed that when Q is, this velocity component is in the direction of magnetic field. If V is in the direction of magnetic field, then it is found that this magnetic force is 0. And when V is in the perpendicular direction of magnetic field, it is found that force is maximum. So sin theta is introduced. Theta may be the angle between, theta is the angle between V and V. It is the angle between V and V. And what is V? V is the strength of magnetic field. Is that clear? So this magnetic force Fm, it will depends on magnitude of charge. Fm will also depends on velocity. Obviously, magnitude of charge, this will help in determining the current. If charge value of charge is more current will flow. Obviously, force will be more. And if velocity is more, so rate of flow of charge charge crossing any cross section will be fast. So again, increase in velocity means current will increase. So again, magnetic force should increase. Experimentally, it is observed that this force is always perpendicular to component V. So actually, Fm should be equal to V sine theta. So I have written two way. Fm is proportional to V and Fm is proportional to sine theta. One more factor remains. It will also depends on the magnitude of external field B. So Fm will also directly proportional to V also. Now if you combine all these factors, what you will find? This force Fm should be proportional to QVB sine theta. Is that clear? Now if you club all these forces, so Fm should be proportional to QVB sine theta, or Fm should be equal to one constant Q into QVB sine theta. Experimentally, this constant K in SI unit, K should be equal to 1. So you will find Fm that is equal to QVB sine theta. This is the force. This is the magnetic Lorentz force. This is the force acting on any charged particle when it enters in external magnetic field whose strength is B and velocity is V by making any angle theta from the direction of B. So this is magnetic Lorentz force. Obviously, force is a vector quantity. So we can also write Fm that is equal to Q into vector V cross B. This thing will help you in determining the direction of magnetic force. Direction of magnetic force will be always such that it will be perpendicular to V. It will be perpendicular to B also. So obviously, direction of magnetic force will be perpendicular to the plane containing vector V and B both. तो इस प्लेन के हमेशा कैसा होगा? It should be perpendicular. So Fm that is equal to Q into V cross B. I think ये clear हुआ सभी को? So this is Lorentz force. Now, if you think about complete Lorentz force, so Lorentz force, that means it will act due to magnetic field as well as electric field. When any charged particle, movable charged particle, it enters in magnetic field as well as electric field, what may be the angle? Suppose its angle is V from the direction of B. So you will observe that charged particle will experience both force. It will experience magnetic force as well as it will experience electric force. So now net force should be vector sum of magnetic force plus electric force. So this combined force is known as Lorentz force. Due to magnetic force, what should be the magnetic force? It should be equal to Q into V cross B. And what about electric force? It should be equal to Q E. Obviously, I have written vector sign, so total sum should be the vector sum of magnetic force plus electric force. If in the absence of electric field, obviously you will have only magnetic force. In the absence of magnetic field, you will have only electrostatic force only. So this is known as Lorentz force. So एक बात क्लियर हुई? कोई भी चार्ज पार्टिकल जब मैग्नेटिक फील्ड में एंटर करता है तो उस पर मैग्नेटिक फोर्स एक्ट होता है. इलेक्ट्रिक फील्ड में एंटर करता है, इलेक्ट्रोस्टैटिक फोर्स एक्ट होता है. And if there is simultaneously magnetic field and electric field, then net force should be sum of both type of force. Is that clear? So these are the net forces, net magnetic forces or net Lorentz force. Now think about trajectory. Trajectory किस तरह की trajectory होगी? Trajectory of charge particle. in uniform magnetic field. Think about its trajectory. Suppose this is any external magnetic field which is directed normal to the plane of paper. This is external magnetic field that is directed normal to the plane of paper and its intensity is supposed to be. So what I have taken? I have taken one external field, magnetic field that is directed normal to the plane of paper whose strength is B. Q is any positive charge. Suppose it is moving with any velocity V and it is in the plane of the paper. Is that clear? Q is any positive charge which is moving with velocity V and this charge is in the plane of the paper. When this charge enters in the external magnetic field, obviously charge will remain in the plane of the paper. Magnetic field is taken normal to the plane of the paper or plane of the blackboard. So obviously direction of V should be perpendicular to B only. Now when this charge particle will enter in the, ये clear हुआ? What I have taken? I have taken Q positive charge. It is moving with V velocity and it is in the plane of the paper. When this charge is in the plane of the paper and magnetic field is oriented normal to the plane of the paper. So now V and B should be perpendicular to each other. Is that clear? Now when the charge particle enters in this field, obviously it will experience Lorentz force. That should be equal to QVB sin 90. This Lorentz force should be equal to QVB. And think about its direction. Force should be perpendicular to V and B both. Is that clear? So it should be perpendicular to V. So obviously, suppose force will be acting in this direction. And it should be perpendicular to B also, magnetic field. So obviously, to remain this force perpendicular to magnetic field, this charge particle will not leave this plane. अगर charge particle इसी plane में रहेगा, तो obviously it will be always remain perpendicular to B also, and force should be in this direction. Now due to this normal force, its direction may be changed. Again force will remain normal. That means in this way you will observe that as this force should remain normal to the motion of any charge particle, that means this force will now serve as centripetal force. So trajectory of charge particle should be circular. Is that clear? Its trajectory should be circular as this charge particle enters. So force, direction of force should remain normal to V and B both. So first case, it should remain normal to B. That means now charge particle will be restricted in same plane only, and it should be perpendicular to V also. That means charge particle should remain normal. So it may serve, this force may serve as centripetal force, and this force may serve as centripetal force. That means now trajectory of charge particle will be always circular. So whenever any charge particle enters normal to magnetic field, its trajectory means path. Trajectory का मतलब होता है path. So उसका path हमेशा ही कैसा होगा? It will remain normal. It will remain circular. And necessary centripetal force. Who will provide the necessary centripetal force? Necessary centripetal force will be provided by Lorentz magnetic force. Necessary centripetal force, it will be provided by Lorentz magnetic force. So centripetal force F should be equal to how much? It should be equal to QVB. And as force is acting in normal direction of V, so obviously direction of B will change, but its magnitude will remain constant. Suppose mass of this charge particle is m. So obviously centripetal force should be equal to how much? mv square upon r. This should be equal to QVB. V and B square cancel. So what you will get? You will get MV upon R, that is equal to QV, or R is equal to, this is the radius of this circular path. R should be equal to how much? It should be equal to MV upon QV. Is that clear? तो यहाँ पर कुछ सिंपल सी बातें हमने बताई हैं. जब भी कोई फोर्स किसी मैग्नेटिक फील्ड में एंटर होता है और अगर मैग्नेटिक फील्ड ओरिएंटेड है नॉर्मल उसके पाथ से, तो ऑब्वियसली जो पाथ होगा, जो ट्रेजेक्ट्री होगी, वो हमेशा सर्कुलर होगी. और उस सर्कुलर ट्रेजेक्ट्री को मेंटेन करने के लिए वॉट एवर सेंट्रीपिटल फोर्स इज रिक्वायर्ड, it will be provided, centripetal force is required, it will be provided by Lorentz magnetic force, and it is equal to QVB. So mv square by r should be equal to QVB. In this way we can find the radius of this circular track. So r should be equal to mv upon r should be equal to, other parameters may also be determined, mv upon QV. Is that clear? Now v is equal to r omega, maybe angular velocity is omega, so you can write r that is equal to m, instead of v you can write r omega upon qb. R and r cancel, so omega is equal to how much? Qb divided by m. This should be the angular velocity. Now omega is also known as 2 pi n or maybe nu is angular frequency. So 2 pi nu should be equal to how much? Qb by m. So nu should be equal to Qb upon 2 pi m. This should be the angular frequency. Time period also, time period t is equal to how much? 2 pi m by Qb. So these may be the parameters of this circular motion. Clear? तो इस तरह से हम आसानी से पैरामीटर्स निकाल सकते हैं. ओनली सिंपल सी एक चीज ली हुई है हमने कि सेंट्रीपिटल का फोर्स mv स्क्वायर बाई r एंड लॉरेंट फोर्स दैट इज QVB. इन दोनों को कंपेयर करोगे एंड यू कैन फाइंड ऑल पैरामीटर दैट इज रिक्वायर्ड. क्लियर? नाउ व्हाट विल हैपन इफ suppose, think another case. Suppose this is the direction of B and B is now not normal to B. In first case I have taken B normal to V and B is not normal to B. Angle between V and B is suppose theta. Is that clear? Or maybe suppose this is B and this is B. Angle between B and B is suppose theta. Now in this case, when the charged particle enters by making any angle theta from the direction of B. So now you will observe that V can be resolved into two components. One component will be V cos theta. This will be along the B. And another component will be equal to how much? V sin theta. Now component V sin theta, it will be perpendicular to B. Is that clear? This V sin theta will remain perpendicular to B. So you will observe that this perpendicular component V sin theta, it will try to move this charged particle in circular track due to Lorentz magnetic force. अपन ने अभी देखा कि if charged particle enters normal to magnetic field then its trajectory should be circular. So as this V sin theta component, this will tend to move this charged particle in circular track. Clear? What about V cos theta? There is one more component, V cos theta. V cos theta is acting in the direction of B. So now here F is equal to Q V cos theta and angle between V cos theta and B is 0. So this force should be equal to 0. Clear? Because sin 0 is 0. So now this force should be equal to 0 and this force will be equal to 0. So no force will be acting in the direction of B. So in this path, this particle will move along a straight line. V cos theta component, due to V cos theta component, charge motion of charged particle should be a straight line. So now the charged particle will possess two type of motion. One circular and another one is this, that is linear motion. Now circular and linear motion, कोई भी पार्टिकल इस तरह से मूव करे कि इट शुड मूव इन अलोंग सर्कुलर ट्रैक और लिनियरली भी मूव करे, ऑब्वियसली इट्स मोशन विल बी हेलिकल. दिस मोशन विल बी हेलिकल. क्लियर? So circular motion, if charged particle is not normal to the plane of the paper, it is not normal to B, then you will observe that motion of charged particle will be helical, and if it is normal, then its motion will be circular. So again for helical motion, you may have the same parameters. Instead of V, you should replace V sin theta. You have to replace V sin theta. Time period, time taken for one complete oscillation, that we have already determined. Time period T is equal to 2 pi m by qb. In this time period, this body will move one circular track, and in this time period also it will move with b cos theta in linear direction. So in one complete rotation, how much distance this body will move? Suppose कोई पूछता है what is the pitch? If we want to determine the pitch, so pitch means total linear displacement in one complete rotation. This is known as pitch. Pitch means total linear displacement in one complete rotation. So displacement, you can simply write velocity in linear direction into in one time taken for one complete rotation, that is time period. So in velocity in linear direction, that is v cos theta, and time period will be equal to 2 pi m divided by qb. This should be the pitch. Is that clear? So in this way we can also find the pitch. Other parameters will remain as it is. Frequency, it will same. Instead of V, you should replace V by V sin theta. So wherever you are getting V, उस सभी जगह पर you will replace V sin theta, and all parameters will be same. Clear? So this is the article related to force acting on charged particle when it enters in uniform magnetic field. Okay, this is our lecture number 4. Okay, thank you.